Welcome to this beginner-friendly guide on C-Sharp editor scripting in Unity, where we'll unlock powerful ways to customize your development workflow, making your process more efficient and tailored. Editor scripting allows you to extend Unity's functionality, automate repetitive tasks, and create more intuitive interfaces directly within the editor, significantly streamlining your development. This powerful customization is achieved by writing scripts that interact directly with the Unity editor during development, crucially without affecting your final game, build's performance, or size. Before diving in, a foundational understanding of C-Sharp programming and familiarity with the Unity editor interface are essential prerequisites, forming the bedrock for effective editor scripting. Specifically, knowing how to create basic C-Sharp scripts, manipulate game objects, and work with various components in the inspector forms the prerequisite knowledge for this tutorial. Our first topic is custom menu items, which let you add new commands to Unity's menu bar, providing quick access to frequently used functions or custom tools, enhancing workflow efficiency. To create a custom menu item, first make a new C-Sharp script inside an editor folder. This folder is crucial because it tells Unity the script is solely for editor functionality and not for game builds. Next, add the Unity editor namespace to your script, as it contains necessary editor classes. Then create a static method decorated with the menu item attribute to define your command. The menu item attribute string parameter precisely defines the hierarchical path to your new menu item within Unity's menu bar, for example, tools/mycustomtool. Finally, implement the desired functionality or custom logic within this static method, which will execute every time your custom menu item is selected. Here's a complete code example demonstrating the structure and implementation for creating a simple custom menu item, showcasing all the elements we've discussed. It's crucial to remember that all menu item scripts must reside within an editor folder for Unity to recognize them, and the method itself must always be declared as static. You can also add convenient keyboard shortcuts directly using the menu item attribute by appending special characters, for example, Ctrl+Shift+Q for quick access. Next, we explore custom inspectors, which allow you to completely change or augment the default layout of a component in the inspector window, providing a tailored user interface. This capability is incredibly useful for managing complex components with numerous properties, making them significantly more intuitive, organized, and user-friendly for developers. To begin creating a custom inspector, you will first need to place a new C-Sharp script within your designated editor folder, just as we did for menu items. Your custom inspector class should inherit from Unity editor, and must be decorated with the custom editor attribute, which explicitly specifies the target component type this inspector will customize. Then, you will override the onInspectorGUI method, which is where you'll draw all your custom inspector elements and logic using various editor layout methods. Here's a comprehensive code example demonstrating how to implement a custom inspector that not only displays default properties, but also adds a functional button. A very useful tip is to use drawDefaultInspector within your onInspectorGUI method to retain all of Unity's default elements while still adding your custom UI elements. For truly robust and professional custom inspectors, it is essential to utilize serialized object and serialized property to correctly handle property changes and undo operations. Finally, let's explore property drawers, which offer a more granular level of control by allowing you to customize the GUI for individual serialized properties. Property drawers are perfect for creating reusable custom controls for specific data types, such as a custom Vector3 editor, or for properties decorated with custom attributes. Similar to custom inspectors and menu items, to create a property drawer, you must first make a new C-Sharp script and place it within your project's editor folder. Your property drawer class should inherit from Unity editor.propertyDrawer and must be decorated with the custom property drawer attribute, which links it to the specific type or attribute it will draw. After specifying the target type or attribute for the property drawer, you will then override the onGUI method, which provides parameters like position, property, and label to draw the custom GUI. Additionally, it's crucial to override getPropertyHeight to accurately define the property's vertical space and height in the inspector, ensuring proper layout. Here's a detailed code example illustrating the complete implementation of a custom property drawer, including both the onGUI and getPropertyHeight methods. It is vital to always wrap your custom drawing logic with EditorGUI.BeginProperty and EditorGUI.InProperty for correct prefab override handling and proper serialization. As a fundamental rule, always remember to place all your editor scripts within an editor folder and consistently use the Unity Editor namespace for editor-specific functionalities. Always use debug, log for effective debugging messages in the Unity console, and thoroughly test your editor scripts in various scenarios to ensure reliability. For modern and scalable custom inspectors and property drawers, consider exploring Unity's UI toolkit and always refer to the official Unity documentation for advanced techniques. Mastering C# editor scripting truly empowers you to tailor the Unity editor to your exact needs, significantly boosting your productivity, enhancing creativity, and streamlining workflows. Thank you for joining this comprehensive step-by-step journey into Unity editor scripting. We hope you found it insightful and are now ready to apply these powerful techniques. Happy coding!